So for this lesson, we are looking at intermolecular bondings. What are the intermolecular bondings? So in the previous lesson, you look at covalent bonding. When we talk about intermolecular bondings, we are not talking about covalent bond. We're talking about what are those other bonds, the bonds between one covalent molecule and another. So this is the forces of attraction between the molecules. So make sure you are clear with that. It is not covalent bonding. It's the attraction between these covalent molecules. So you see, these forces play a crucial role in determining the physical properties of the substance. There are three main types of it. The first one is known as the permanent dipole-dipole interaction. So in a permanent dipole, you're talking about molecules that have uneven distribution of electrons. As you can see, uneven distribution of electrons between the atoms. So it results in partial positive and partial negative charge. An example here will be hydrogen chloride. So hydrogen here in general will be partially positive, chlorine will be partially negative because chlorine is more electronegative than hydrogen. So when it creates that partially positive, partially negative, if you can see on the diagram on the right, it creates what we call permanent dipole or dipole-dipole attraction. You may say that, but this is not ionic compound. It is not. It is not an ionic compound. So why does it have positive and negative ions? So these are not ions. These are just partial positive and partial negative charge because of the difference in electronegative value. If you look at your periodic table, chlorine is more electronegative than hydrogen. That's the reason chlorine is partially negative, whereas hydrogen here will be partially positive. When we look at temporary dipole, induced dipole, in this case mentioned as London dispersion forces, it says here these are the weakest type of intermolecular interaction. The general story behind temporary dipole is that all molecules have temporary dipole, even those that does not have differences in electronegative value. So I read this for you. They arise due to momentary distribution of electrons, which creates a temporary dipole. An example of noble gases like neon. Neon atoms do not have permanent dipole because they are non-polar, but at any given moment, the electrons in neon atom might be unevenly distributed, creating a temporary dipole, as you can see here. So even though you're talking about molecule, as you can see here, or atoms, not necessarily a molecule, even atoms, uh, that in this case they are not bonded to one another, but they have what we call temporary dipole because of the movement of electrons. As you know, electrons is the only subatomic particle that is capable of moving around the nucleus of the atom. So there will be tendency of electrons being concentrated on one end or the other, and that creates what we call the temporary dipoles. The last one will be hydrogen bond. So hydrogen bonding is a special type of double-double interaction that occurs when hydrogen is covalent bonded to highly electronegative atoms such as nitrogen, oxygen, or fluorine. So it has to be a bond between hydrogen and nitrogen, or hydrogen and oxygen, or hydrogen and fluorine. It says here the hydrogen atom having a partial positive charge is attracted to a lone pair of electrons on neighboring electronegative atom, forming a hydrogen bonds. So hydrogen bonds are a lot stronger than temporary dipole and any other dipole, but it's weaker than covalent or ionic bonds. And the story behind this is because hydrogen bond is actually a type of permanent dipole, but specifically when hydrogen and nitrogen is present, or hydrogen and oxygen is present, or hydrogen and fluorine is present. As you can see on the diagram on the right, we have H2O water molecules. There's hydrogen bond between them. Once again, hydrogen bond is not covalent bonding. What you are learning here, the intermolecular bondings, they are not covalent bonds. They are the bonding in between those covalent molecules. And because of that, it forms the hydrogen bonds between the water molecules. And story behind here is this oxygen is more electronegative than hydrogen atoms, creating a partial negative charge on the oxygen and a partial positive charge on the hydrogens.